In this section, we will learn about the concentration of a solution, how to calculate concentrations, and some practical applications of solutions. Think about the frozen concentrates for fruit juices that you can buy from Publix. They are concentrated because they have a large amount of solute in a small amount of solvent. Concentration is defined as the amount of solute divided by the amount of solvent. Concentration can be expressed as mass percent, volume percent, mass to volume percent, or molarity. Recall from chapter 1 that when you are given a percent, it represents the number of parts in 100 of those items. So 90% on an exam equals 90 correct answers out of 100 questions. And 5% red balls equals 5 red balls out of 100 total balls. In the same way, concentration given as a percent, such as 8.50% by mass sodium hydroxide, means you have 8.50 grams of sodium hydroxide in 100 grams of sodium hydroxide solution. You can obtain two conversion factors from any given concentration. This table provides a summary of how you extract meaning from concentration terms. Note how for every concentration you can obtain conversion factors that help you convert between amounts of solutes and amounts of solvents. The final concentration term we will look at is called molarity. This relates the moles of solute to the volume of a solution. Molarity is defined as moles of solute per liter of solution. Pause the video and recall what a mole is. If you've forgotten, refer back to your notes. The unit for molarity is mole per liter, and this can be represented by capital letter M. So a molarity of 3.5 m of HCl means 3.5 moles per liter of HCl solution, or that 1 liter of HCl solution contains 3.5 moles of HCl solute. From that equality, you can derive two conversion factors to convert moles to liters or to convert liters to moles. Sometimes it is important to dilute a given solution. For example, we must dilute the frozen juice concentrate before we can drink it. During a dilution, you add water to a solution. This causes the overall volume to increase. Since concentration is the amount of solute divided by volume of a solution, the concentration decreases. Importantly, however, the amount of solute remains the same since you only added water and you didn't add or remove the solute. Since the moles of solute don't change during dilutions, and moles are obtained by multiplying concentration C by volume V, the product of concentration and volume will remain the same during dilutions. Therefore, C1 times V1 is equals to C2 times V2. When given 3 of the 4 quantities, you can use this equation to find the fourth. Here's one example. Pause the video and attempt the problem before proceeding. In the problem, we are given initial volume and initial concentration. We are told that the solution was diluted to a final volume V2 of 1.0 liters. Since this is a dilution problem, the moles of hydrochloric acid didn't change. So C1 times V1 is equal to C2 times V2. Rearrange the equation to find C2 and substitute the given quantities to solve the problem. Check the significant figures and confirm that the concentration is smaller, since after dilution, volume increases, concentration decreases, and moles of solute remain the same. Recall the classification of mixtures as solutions, colloids, and suspensions. One way to distinguish a colloid from a solution is that particles in a colloid are generally too large to pass through a semi-permeable membrane. Solutes in a solution, such as ions, atoms, and small molecules, seen here as yellow circles, are small enough to pass through a semi-permeable membrane, while particles in a colloid and suspension, e.g. larger molecules, are trapped. Many biological processes take advantage of the different ways that particles move through different media. Imagine that you spray your perfume or cologne in one corner of your room. After a short while, the fragrance will fill the entire room. Why is that? It's because the perfume particles moved from where you applied them to the rest of the room. That movement of particles from an area where they are concentrated to an area where they are more dilute is called diffusion. Unfortunately, less pleasant gases also travel through air by diffusion. Osmosis is a special type of diffusion. It involves the diffusion of water molecules across a membrane that allows small water molecules to pass through, but prevents larger molecules, such as sucrose molecules, from passing through. Such a membrane is called a semi-permeable or partially permeable membrane. Note that the side where the water concentration is high, the solute concentration is low. Since water molecules are the only ones small enough to pass through the membrane, water will flow into the solution with a higher solute concentration. This process will continue until the flow of water is equal in both directions. Since more water will flow from left to right, the final solution level will be higher for the side with a higher solute concentration. The pressure that is required to stop osmosis is called osmotic pressure. Since osmosis is driven by a difference in concentration, the more concentrated the solution is, the higher the osmotic pressure. If a pressure is applied at the concentrated solution, water can be forced out of the concentrated solution. This is called reverse osmosis. Reverse osmosis is used in a few desalination plants to obtain pure water from seawater, but this requires a large amount of energy. When comparing the osmotic pressures of two fluids, we can use the terms isotonic, hypotonic, or hypertonic. If a solution has the same osmotic pressure as red blood cells, the solution is isotonic. Remember that the prefix iso means same. If a solution has a lower solute concentration relative to blood cells, the solution is hypotonic. Remember that the prefix hypo means under. For example, hypoglycemia is low blood sugar. If red blood cells are placed in a hypotonic solution, water will flow into the red blood cells through osmosis, causing the cells to burst. If you place red blood cells in a hypertonic solution, which has a higher solute concentration, the cells would lose water through osmosis and shrink. Remember, the prefix hyper means excessive or above normal. One major application of particles passing through a semi-permeable membrane is dialysis. Through dialysis, your kidneys remove excess water and small solutes such as sodium and chloride ions from blood while retaining larger colloidal particles such as proteins. We have come to the end of chapter 9. Come to class prepared with questions about concepts and sections that you need me to go over in class. And as always, happy studying.